everyone. Today our chapter is Matter in Our Surroundings, Part 3, which is the continuation of Part 2. In this part, we are going to know about evaporation, factors of affecting evaporation, 5 states of matter and important measurement units. Okay, first we will know about what is evaporation. See, we already know that particles of matter are never at rest. They will always be moving. Yes. Yeah. Particles of matter also possess different amounts of kinetic energy. See, what is kinetic energy? See, because of the movement of particles inside the matter, there is energy created, that is kinetic energy. Yeah. So, the particles of matter possess different amounts of kinetic energy. So, there is a different forms of kinetic energy in each and every different matter. Okay. Now, the particles of liquid have more kinetic energy. See, these liquids particle have more kinetic energy. Therefore, they are able to overcome the forces of attraction and convert into vapor. See, what should happen from the conversion of liquid to gas? There should be no force of attraction between the particles. So, there is, in this liquid, they are able to overcome the forces of attraction to convert themselves into what? Gaseous or vapor state without any external forces. You no need to apply any external forces like more effort. So, just if you heat, it's enough to get liquid into a vapor state. Okay. Next, evaporation. If you see here, the definition we'll know here. The phenomenon of change of liquid into vapors at a given temperature below its boiling point. See, boiling point is 100 degrees Celsius. See, after that, however, the evaporation takes place. Before that, evaporation is different than boiling. You can see here, evaporation and boiling both are different. Here, the particles are evaporating. If you say in boiling, the particles are here only, what do you tell, moving here. See, this vapor pressure is lesser than that of the atmospheric pressure. Bubbles cannot be formed here. Here, vapor pressure is equal to atmospheric pressure and bubbles can form and rise. This is about the evaporation and boiling. So, overall, what is evaporation? The phenomenon of change of liquid into vapors at any given temperature below its boiling point is called evaporation. Okay. Next, now factors affecting evaporation. What are the factors that affects evaporation? If you see, what is increase in surface area? If there is increase in surface area, if it is more, the rate of evaporation is also more, increases. This is directly proportional. Increase in surface area increases evaporation. Okay, because of that reason, what is the reason? Because of this, particles have more space here. See, if you increase the surface area, there will be more space and thus evaporation occurs easily. Okay, this is about surface area. Next, if you come increase in temperature, even if you increase the temperature, evaporation also increases. Why? Because the kinetic energy among the particles increases. Because of the kinetic energy is increasing, increase in rate of evaporation is also happening. Okay. Next, increase in humidity decreases evaporation. Why? Water content in air increases. See, if the water content is increasing still more and more, evaporation is obvious, it is decreases. Okay. Next, increase in wind speed also, it increases the evaporation. Why? Water vapors are blown away by winds, allowing more evaporation. See, 4 things. What? If there is an increase in surface area, the rate of evaporation increases. If increase in temperature, evaporation increases. Increase in humidity decreases the evaporation, and increase in wind speed increases the evaporation. Okay, this is about the factors affecting evaporation. Okay, next, how evaporation causes cooling. The process of evaporation uses the energy of the liquid particles. See, what happens? The process of evaporation is using the energy of the liquid. Liquid's energy only it is using. What? The process of evaporation. Therefore, the particles absorbs energy from the surroundings. During this process, the particles absorbs energy from the surrounding. What? In order to compensate the energy that they are losing. Yeah, they are losing energy, right, because of the evaporation. So, to compensate that, there is an absorption of energy from the surroundings. Okay, to compensate the energy that is being lost in the process of evaporation. This results in the cooling of the surrounding area. Okay, so if evaporation is happening, the surrounding area will be cooled. Okay, here if you see in this picture, see this is high energy evaporating, medium energy pulled back into water, and lower energy remain as a liquid. Okay, this is about how evaporation will cause cooling in the surface surrounding area. Okay, next, for example, if you take, our palms feel cool when we put some acetone, that is a nail remover or something else. Okay, and people sprinkle water on the roofs. Why? Because to make them cool inside under the roof. And we are able to sip hot water in a hot tea faster in a saucer than in a cup. Why? Because you know the reason. Yeah, because of the cooling effect when there is an increase in the surface area. Okay, so that you can drink fast. Then, why people wear cotton cloths in summer? Why do they wear cotton cloths in summer? We perspire more in summer, that is, we sweat a lot in summer. Yeah, as the sweat evaporates, it takes energy from our body also. Yeah, see, if there is more sweat occurring in our body, even we lose energy from our body surface and keeps our body cool. So what happens? Cotton can absorb the sweat easily. It absorbs the sweat easily and exposes it to the atmosphere, causing evaporation to take place easy. See here, cotton makes evaporation easy from our body. Okay, this in turn keeps us cool in summer days. So cotton cloths make us cool in summer days. So even if you go out in a summer, like the beaches and all, we wear more cotton cloths. Okay, next, why water droplets appear on the surroundings of a glass? See, if you open the fridge and if you take a water bottle, after some time you can see water droplets around the water bottle. Why? These are the water vapors present in the air. See, if this is the water vapor react with this cold thing and the water droplets is formed. Okay, when these water vapors come in contact with the walls of the glass, of that ice cold water in it, they condense. As a result, their state changes from gaseous state to liquid state. So water is becoming gaseous state, that is vapor is becoming into a liquid state, that is they form a water droplets around the surface, thus forming a tiny water droplets on the walls of a glass. Okay, this is how the water droplets appear on the surroundings of a glass ice cold water. Okay, next, the 5 states of matter. The 5 states of matter. By far we know all the 3 things, that is solid, liquid and gas. But scientists have discovered that there are 2 more states of matter, that is plasma and Bose-Einstein condensate. You also call it as BEC, that is Bose-Einstein condensate. Okay, we'll know about that. Okay, these are the matter 5 states, that is solid, liquid, gas, plasma and Bose-Einstein condensate. Now we'll know about plasma. This is a state of matter in which the particles are super excited. Okay, gas is very free, but these particles are very super excited and super energetic. They are in the form of ionized gases. Okay, for example, if you take fluorescent tubes and neon light bulbs consist of plasma. They are very, very super excited and energetic particles. So they are made of plasma matter. Okay. The neon bulbs contain neon gas, and there is another gas such as helium in it in fluorescent tube. Now, what happens as electricity is passed in the tube or the bulb, these gases get ionized, and this creates the plasma inside them that glows. Okay, this is how the neon bulbs work. Okay, this is all made up of plasma matter. Okay, understood. Next. Now, in fact, the sun and the stars glow because they have the plasma matter in them. Okay, stars, sun, you can see lightning, neon lights, plasma TV, these are all having the plasma matter in them. Okay, these are the examples: stars, lightning, neon lights and plasma TV. Now coming to Bose-Einstein condensate, that is BEC. Now this is the fifth state of matter discovered by whom? Albert Einstein, on the basis of the studies conducted by an Indian scientist, Satyendranath Bose. Okay. Now BEC is formed by condensing gases. Here gas is getting condensed of extremely low densities. At extremely low density, the gas is condensed at a much lower temperature. At that time this state is formed, that is Bose-Einstein condensate. Okay. Next, important measurement units. See, now we'll know about the SI units. Okay. First we'll know about SI unit of volume, that is meter cube, or you can tell cubic meters. Then common unit of volume is liters. Then SI unit of temperature is Kelvin. Okay. And SI unit of pressure is Pascal. Then for measuring pressure exerted by gas, that is atmospheric pressure, or normal atmospheric pressure is equal to 1 atm at sea level. Okay, this is about the important measurement units.